Hello, everyone. This is Mr. Amen broadcasting my first video to try and help you guys with science. It looks like the assignments that have been given so far, they're all Discovery Ed. And I'm not sure if that's how everybody learns, but I just wanted to give you guys some video assistance to help you. If you're wondering where I got this picture or the definitions down below that you can currently see, please know that that is all available to you online. I put them on Schoology. It's a PDF. You guys can either print it out, you can copy it. If you don't have access to a printer, you can simply draw these boxes as we go. So those are the only solutions to the problem that we have right now. But we'll see what happens. We'll see if you guys like this. So in order to teach you waves, I gotta teach you from the very beginning. So I'm gonna cover 5 of these blocks in one video and then try to do it again. So I'm gonna scroll down first to the definition of wave, and I'm gonna draw it. It says a wave is a disturbance that transfers energy from one location to another. So energy is the ability to do work, and somehow we can transfer that from one spot to another, which is ridiculous if you think about it. So forms of that are light, sound, even seismic waves. So let's just draw light waves to begin. So I'm going to draw a flashlight. And I'm not the best artist, but you guys know me well enough that you just have to deal with me. Okay. Okay, so there's a flashlight. You know what? That's really good. I don't care what you guys say. All right, now this is a wave. And we'll learn more about why it looks like this in the future or what it is. And let's just pretend that these little green squigglies are energy. So this wave carries energy from one spot to another. So we got those 4 little squigglies of energy. And energy is carried by the wave over to here. Hopefully that explains a wave for you. Wavelength. Wavelength. That makes sense. It's like the length of a wave. That's right. And the definition they give you is the length from corresponding points of one wave to the next. So I don't even know if you know what corresponding points means. So let's just take it one step at a time. First, we're going to draw a line. Might not be perfectly straight because I'm not the best at drawing. So we're going to now draw a wave on it. And by the way, that line is called the node line. Okay, so a wavelength is basically the length of a wave. Its corresponding parts. And I'll show you what that means. But first, you want to know that the symbol for wavelength is that right there. Let's keep going. Here's one part of a wave. Here's a very similar part of that wave. These are 2 crests of a wave, one after the next. So the distance from one crest to the next, they're corresponding. They're similar. That's known as the wavelength. And then if you go from trough to trough, down here. Okay, those are the bottom parts of the wave. The trough, that's a wavelength. You can even take 2 spots that are similar in the wave that people wouldn't normally get. Like you could take the upslope here. I go right here, and then I'll go to the next upslope, which is right here. Same height. That right there is a wavelength. Okay, so just know it's corresponding parts of a wave, the length between the 2. Now, the next one, it says wave speed. But the problem is you don't even know what frequency is yet. So wave speed, you need frequency to determine. So I'm just going to go straight to frequency. Frequency, you scroll, it is the number of waves that pass in a given amount of time. Example, 2 waves a second. So let's show a graph. The only way you guys can learn this is to see it. So, oh, and by the way, you will see it. I'm going to sing in this mic in the future, high and low, and you're going to see different frequencies. That will be weird for me, but it's okay. So let's just draw a quick graph. And we're going to pretend that right here you have 0 seconds, and then here is 1 second. Like so, frequency would be number of waves that pass by in a second. So let's just draw some different waves and determine its frequency. I guess I'll write time down here, and then I'll just put a W for waves here. All right, first one. Okay. The way you determine how many wavelengths there are, so it's how many wavelengths pass by in a given amount of time. So in 1 second, I'm just going to count the crests. I think that might be okay. I could count the troughs, and I can tell right now that the troughs, the bottom parts of the wave, would be slightly different, but here and here, could imagine that could make up a trough. So I'm just going to count the crests. That'll be the way that we do it. So I'm going to go 1, 2, 3, 4. So the frequency of this would be 4 hertz. That's the unit for frequency. So 4 Hz. So I'm going to put a little F here for frequency, and I'm going to put in parentheses, parentheses, I'm going to put hertz because that's the unit for frequency. Let's try another one. We'll go green. And you don't have to be exact with me. I'm just trying to show you a pattern. So this wave here, I'm going to count the crests. 1, 2, 3, 4, 5, 6, 7. So this one is 7 hertz. It's an ugly 7. I know. Next one. I can think of like 6 of you right now that would give me a hard time about that. Next one. There's a lot. Okay. Count the crests. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 hertz. So that's the frequency. It's the number of wavelengths that pass you in a given amount of time. All right, now let's go to wave speed. Wave speed, if we scroll down, look at that definition. It's how fast a wave travels from one place to another. And you'd think that that kind of has to do with frequency, but it really doesn't. You see, the speed of waves can change. And a good example of that would be, say I yell in this room right now, right? And now I go underwater and I yell. The speed in which my sound wave travels would be different compared to where I'm yelling. In fact, you'll find in the future when I go over this that different areas, it could even have to do with temperature, different spots, energy travels faster or slower in those different places. So, yeah, you'll get that in the future. But let's determine how to find wave speed. So I'm going to draw one of those triangles because, yeah, it's a 3 variable equation. I'm going to put the little line here. And wave speed, we can also call it wave velocity. So at the top of the triangle, put a V for wave speed. So wave speed, or wave velocity, is measured in meters per second. So wave speed equals frequency, all right, so frequency, which is measured in hertz, times the actual wavelength. So wave speed equals frequency times wavelength. I'll write it right here for you. V equals F times wavelength. That's how you calculate wave speed. So if anybody gives you an equation for that, um, or sorry, if anybody gives you a problem, you have the equation for it now. Finally, a medium. Waves travel different through different mediums. So let's figure out what mediums are. If we scroll to M, medium, a material substance in which energy is transported. Okay, so it's anything. And what can anything be made of? Well, we have choices. And those choices include solid, liquid, and gas. So I'm drawing a cube, putting an S on it for solid. Okay. Then we go on to liquid. And yes, it's a water droplet. And then finally, you have a gas. And I'm putting little dots to represent gas. So we know solid has definite shape, definite volume. Liquid, indefinite shape, indefinite volume. Or sorry, and it has a definite volume. And then with gas, gas just likes to spread out. You can calculate its volume by containing it, but it's tough. All right, now let's show what medium is. It says it's a material substance which energy is transported through. So I'm just going to draw energy transporting through each of these mediums. Right now, just so you guys know, sound energy is being transported from my vocal cords into this microphone. So from here to here, waves are traveling, energy is traveling, and it's traveling through gas. Hopefully, that concludes our first video. Hopefully, you guys don't have too many questions, but if you do, make sure you contact me as soon as you can.